So let's have solution to example 5. Calculate the moment of the 250 Newton force on the handle of the monkey wrench about the center of the bolt. Solved in two methods, by direct and by Varignon's theorem. So for the direct method, I'll present it here. For the Varignon's theorem, I will leave that to you. So for your practice. So this is the monkey wrench. So the Varignon's theorem is simpler because all you have to do is resolve the force into components. I have to present it using the direct method. So this is point O, and I extend the force so that it's clear here that we form a right triangle. The hypotenuse is the distance from O to the point of application of the 250 Newton force, and it is equal to square root of 200 square plus 30 square. So that's it. So this is the distance from O to the point of application. This is the perpendicular distance, and the sense is obviously clockwise. So I'll call this theta. This angle is theta from horizontal to this inclined line. So this is 15 degrees because by principle, the angle between the vertical and the force is 15. So that's the inclination also of this perpendicular line or this inclined line. So 15 degrees. So therefore, the total angle is theta plus 15 degrees. So theta is arctan of 30 over 200. So this is the hypotenuse times cosine of theta plus 15 degrees, the moment arm. So moment about O is 250 times d cosine of quantity theta plus 15 degrees, and the sense is clockwise. So d is 200 square plus 30 square. So d is, and tangent theta is 30 over 200. So theta is 8.531 degrees. Substitute, MO is 250 times d, which is square root of 200 square plus 30 square, times cosine of quantity 8.531 degrees plus 15 degrees. So moment about O is equal to 46355 Newton mm. The sense is clockwise. If we divide everything by 1000 to convert it to Newton meter, it is equal to 46.36 or 355 Newton meter. And the sense is clockwise. So I leave Varignon's theorem for you to solve the same problem and make sure that the answer is the same. Example 6, the cable AB carries a tension of 400 newtons. So determine the moment about O of this tension as applied to point A of the slender bar. So we have an angle here 30 degrees. So if we draw a line, horizontal line here, then this angle is also 30 degrees. So the length of this horizontal line from A is 500 cosine 30. And this is the tension force of magnitude 400. Remember, tension is away from the point of application. So this is also 30 degrees. So 500 cosine 30 degrees. This is because this is 30 degrees. Then this vertical distance is 500 sine 30. So that's 250 mm. Again, 250 is 500 sine of 30 because this is 30 degrees. So 650 mm minus 250 mm is 400 mm, so that we can solve for this angle here. And that's 30 degrees, called the theta. This is the perpendicular distance by direct way. So the moment arm or the perpendicular distance is 500 times, because this is opposite to theta and 30. So 500 times sine of theta plus 30 degrees, where theta can be solved from this right triangle here. Tangent theta is 400 over 500 cosine of 30 degrees. So solving for theta, theta is 42.73 degrees. Then The moment is 400 times 500 sine of quantity theta plus 30 degrees. So MO is 400 times 500 sine of 30 degrees plus theta, or theta plus 30 degrees. So solving for MO is 190983 Newton mm, and the sense is counterclockwise. Obviously, this moment arm will rotate counterclockwise. So that in Newton meter, it is 190.983 Newton meter counterclockwise. So that's the answer. By Varignon's method, so MO is 400 cosine of 42.73 times the horizontal component of 400. Then the moment arm is 250, and that is counterclockwise. The vertical component is 400 sine of theta, and the sense is also counterclockwise because that's upward. So this will rotate counterclockwise, this moment arm. The moment arm is 500 cosine 30. So 400 sine of 42.73, the moment arm is 500 cosine 30. And they have the same sense. The x and the y component, of course, have the same moment about O, which is counterclockwise. So computing, MO is the same, 190.983 Newton mm counterclockwise, or 190.983 Newton meter counterclockwise. Then another method, by principle of transmissibility of a force, I move the 400 Newton force at B. This angle here is theta. There are two components, vertical and horizontal. But the vertical component has no moment arm. It passes through point O. Only the horizontal component will have moment about O. And the sense of the moment of this horizontal component about O is also counterclockwise, because this is the moment arm, which is equal to 650. So if you drag it to the left, this moment arm will rotate counterclockwise. So the x component of the force is 400 cosine of 42.73, and the moment arm is 650. So moment about O is 400 cosine of 42.73. The moment arm is 650. The result is 190.985 Newton mm counterclockwise, or 190.985 counterclockwise. There's a very small discrepancy is due to the value of theta, which is rounded off only to two decimal places. So if you copy all the value of theta, all the three will be the same. So